All right, hello there. In this video I'm going to go over the solution to question number 11 from the Practice with Areas worksheet. We give a quick read through the question. We start the region bounded below by the parabola y equals x squared and above by the line y equals 4 is to be partitioned into two subsections of equal area by cutting across it with the horizontal line y equals c. Part A. Sketch the region and draw a line y equals c across it that looks about right. In terms of c, what are the coordinates? So first thing I'm going to do is sketch the region. We've got the parabola y equals x squared and the line y equals 4. And we're going to sketch in the line y equals c. That looks about right. It's going to be a little bit more than halfway across there. Okay. In terms of c, what are the coordinates of the points where the line and the parabola intersect? Add them to your figure. So we're talking about these 2 points here and here. We know that the y coordinates of these points are both c. And so the x coordinate on this side is going to be, since this is the parabola y equals x squared, it's going to be the square root of c. And then on the other side, it's going to be negative square root of c. So those are our 2 points. All right. Part B asks us to find c by integrating with respect to y. All right. So if we're integrating with respect to y, that means we want our limits of integration and we want our integrand. We want all of that to be y values. So what we're going to do in order to find c here is first we have the bigger parabola, the whole parabola, which I'm just going to slash through in blue there. That's going to be the integral from one end of the parabola to the other. And since we're going in terms of y, we're going to go from the bottom of the parabola to the top. And so this is going to be the integral from 0 to 4 is going to be the area of that parabola. And then I just need the integrand. Now, since we're going in terms of y, our strips are going to run from one side of the parabola to the other. And so they're running from the positive branch of this parabola when we put it into x equals function of y form. Remember, the parabola was y equals x squared, so if we solve that for x, we've got x equals plus or minus the square root of y, which makes the right-hand branch of this x equals the positive square root of y. So let me just give that a quick highlight. That's the positive branch over here. And the negative branch is going to be x equals negative square root of y. And so that's going to be this branch over here. So our integrand is our rectangles are running from square root of y to negative square root of y, which makes the height of those rectangles square root of y minus negative square root of y. And we're integrating all of this with respect to y. That's going to be equal to twice the area of what's underneath the curve. Okay, and what's underneath the curve, again, we're going to start from the bottom end and go up to the top of that region. So that's going to be the integral from 0 to c of the same integrand and now we just need to go ahead and solve this for c. So simplifying a little bit, we end up with integral from 0 to 4 of 2 root y dy is equal to 2 times the integral of 2 root y from 0 to c. Integrating both sides of this, let's see, the integral of square root of y is 2/3 y to the 3/2. So this becomes 4/3 y to the 3/2, evaluated from 0 to 4. And the right-hand side here becomes 8/3 y to the 3/2 evaluated from 0 to c, and that gives us the equation that 4/3 times 4 to the 3/2 is equal to 8/3 times c to the 3/2. Multiplying both sides by 3/8, we end up with c to the 3/2 being 1/2 times 4 to the 3/2. So c is going to be equal to the quantity 1/2 times 4 to the 2/3, 4 to the 3/2, all raised to the 2/3. And I'm going to go ahead and punch that up on my calculator here. And so we've got quantity 1/2 I can barely see my calculator. 1/2 times 4 to the 3/2, all raised to the 2/3, and we get 2.520 for the value of c, or 2.519 depending on if you decide to truncate around. Alright, so that's part B. When we turn around and look at part C, we're going to approach this in a slightly different way. Give myself some space here. I don't want to clean out that diagram. Because I'm going to use that in the next portion. Alright, so let's go ahead and scroll up. Now in part C, we're supposed to find c by integrating with respect to x. So we want everything to be in terms of x's, in this case. And so the integral of the whole parabola, we're going to go from the left end to the right end. So that's from -2 to 2. So we've got that the whole area is integral from -2 to 2 of, and this region is defined by the line 4 minus the parabola x squared. And so that's the area of the entire region. If we want to do the bottom half of it, we're going to have the integral from -√c to root c of the quantity c minus x squared dx. Now those aren't equal to one another. The area over here on the left-hand side is 1/2 of the area below the line y equals c. Alright, so now I need to integrate all of this. Since I don't have any c's on the left-hand side, I'm just going to go ahead and save myself some time and energy and use the numerical integral. And that tells me that the left-hand side here is 16/3. And then I'm going to integrate the right-hand side. The integral of this becomes cx minus x cubed over 3, which we're going to evaluate from -√c to root c. And so we've got 16/3 is equal to, and now we substitute root c in here for x, gives me c to the 3/2 minus c to the 3/2 over 3 minus the quantity negative c to the 3/2 plus c to the 3/2 over 3. And simplifying the right-hand side here, we end up with, let's see, we've got 2/3 of them plus 2/3 of them. So that ends up being 4/3 c to the 3/2. And so we've got that c to the 3/2 is equal to 4. And we go ahead and calculate. And c is going to be equal to 4 to the 2/3. And again, we end up with 2.520. Showing that whichever way we calculate that area, whether we calculate it in terms of x or in terms of y, the value of c that divides that region into two equal portions occurs at exactly the same place, which of course is a nice thing. It's exactly what we would want in a methodology, that we can handle it in either of these two ways and still end up getting the same results. Hope that answered your question, and I'll talk to you again soon. Bye-bye.